You. Hello, everyone. My name is Nishi Ajmera. I work as a solutions architect in Publicis Sapient, and I have been building agents for more than 2 years now. We have been building agents for our clients. We have been building agentic platforms. So, I I am like closely following the whole AI space, and I'm passionate about AI. I do a lot of talks around AI agents, specifically agents now for like last 1.5 years. So yeah, and I'm also a Google developer expert in AI and ML, also a Perplexity fellow. So today we are going to talk about the Google's A2A protocol. It's basically how agents communicate, how you communicate with different agents which are deployed or built using different frameworks, deployed on different cloud environments, different platforms. So let me share my screen and then we'll get started. Hmm. Is my screen visible?
Yeah.
Okay. All right. So this is the PPT which I have, and I did something. I love Claude, so that's why I created this visual kind of thing, which these are basically slides which talks about like the concepts within A2A. So I would probably switch between the PPT and these slides. So just bear with me, and if anything is not clear anywhere, just prompt me. So the agenda, like what I'll do is we'll start with what the problem is, what problem the agent to agent protocol is trying to solve. What is the A2A protocol? We'll talk about the core concepts of the A2A protocol. We'll go into the technical details of how the communication happens between two agents. We'll talk about the communication methods. We'll talk about how the message is constructed. We'll go into all those details. Then I'll briefly touch up on how A2A is different from MCPs and how A2A and MCP work together. We'll also talk about the security aspect, how the authentication authorization works when two agents are communicating with each other. We'll talk about the observability part of it. And then towards the end, I have a very simple demo. We'll do a quick walkthrough of that demo, and I can then share you the GitHub repo. You can do a clone of it and you can run that application for yourself and understand how it works. So yeah, that's the agenda. Right. Let's get right into it. So first, let's start with the problem which A2A is trying to solve, right? So the problem which A2A, the current problem is everyone is building agents using their own framework. So you might have used LangGraph to build your agent. Some people would be using Crew AI to build their agents. Some people would use Google ADK to build their agents, right? Now, how do you make these agents talk to each other, because these agents would be deployed in their own environment? I would have an agent which is deployed in, let's say, Google Cloud. Someone else has an agent which is deployed in Azure. You may have an agent which is deployed on-prem, right? So how do you make sure that, how do you make these agents talk to each other? Now, one of the solutions before the A2A protocol came into picture, it was to basically wrap these agents as a tool and provide that tool to the to your orchestrator agent or your the main router agent. So you would either expose your agent as an MCP server, and then you would like give that MCP server to your orchestrator agent, right? So that was one way where a lot of people were like trying to make their agents talk to each other. Now the problem with exposing your agent as an MCP server, like an MCP server with one tool, which is basically calling your agent. The problem is that MCP server works on a strict schema, input output schema, right? So when you're defining tools in your MCP, you're defining an input schema and you define an output schema. The input schema, output schema, the name of the tool, description of the tool, all of this goes into the context of your orchestrator agent, right? All of this will go into the system prompt of your agent. And then when your agent will figure out, like, based on the query, whether it needs to call that tool or not. Now in this scenario, you're still working under your orchestrator agent, like your the sub agent or the remote agent which you're trying to call is still working under the orchestrator agent. There's no isolation of that particular agent. We'll understand this a bit more in the future slides. So that was the problem. There wasn't any defined standard or a protocol of interacting between like of making two agents communicate with each other. So that's where your A2A protocol came into picture, right? So A2A is agent to agent protocol, which is an open standard that lets AI agents built on different frameworks by different teams deployed in different environments communicate with each other over a common language. So there's a common set of rules which are defined, and they communicate using those set of rules or protocols. It is built on existing standards. So it uses HTTP, HTTPS protocol, JSON RPC. It also supports SSE events, and it uses OAuth2 and OpenID Connect for authorization, authentication authorization, right? And it can work across different frameworks. So you can build your agents in any of these frameworks, can deploy in any of the cloud premises. Now, how does this work? So how does an A2A protocol work? So it is again a client server model. You will have a A2A client, which would be talking to an A2A server, right? So your client agent is your router agent or is your orchestrator agent, and that client agent is responsible for discovering the remote agents, figuring out which remote agent to delegate the task to. It is responsible for receiving the results and then sending the result back to the user. So this is your orchestrator agent. And then you have your server agent. Server agent is your remote agents. So you can have, like, a classic example is of your travel agent, right? So you have a travel agent. Now if you have to book a trip from London to Paris, let's say for a 7-day trip, you would need hotel bookings, you would need flight bookings, you would need to book attractions. There are you will have to, like, if you need visa or some other things, like there are so many things which you need to take care of when you are planning a trip, right? So now you have an orchestrator agent, travel agent. You go to the travel agent and you just give all your requirements to it. Now your travel agent will figure out which task to delegate to which agent, right? So you can have a flight booking agent, you can have a hotels booking agent, you can have a attractions agent, right? So your travel agent is here, your orchestrator agent, that is your A2A client, and your hotels booking agent is your A2A server. Your flight booking will be another A2A server. Your attractions would be another A2A server. All these are remote servers, can be deployed anywhere in any of the cloud environments, or in, like, built using any of the frameworks, right? So these server agents, they receive tasks, they execute them, they return the results, and they operate as a black box. You don't know what logic is there within that agent, what framework it is used to like what framework is used to build that agent, what kind of memory, what kind of tools it is using, what models it is using. You are not worried about, like, it is a black box for you or for the orchestrator agent. Then how does the discovery mechanism work in A2A protocol? So the A2A protocol uses something called as agent card. So agent card is a JSON which has all these details. So it will have the name of the agent, the description of the agent. The description will have, like, what the agent does, uh, provider, like who this agent is, who is providing this agent, then the endpoint where the endpoint which you can use to communicate to this agent, those details will be there in your agent card. Then it also describes the capabilities which the remote agent supports. So if your remote agent supports streaming, then the streaming capability will be true. If it supports push notification, then that push notification capability will be true. We'll get into the details of how streaming and push notification work. So capabilities are basically define whether your agent supports synchronous or asynchronous communication. Then what kind of authentication is needed for this particular agent? If you have to communicate to this agent, what kind of authentication it supports, that is defined in your agent card. And then lastly is the skills. It's like what kind of tasks it can perform. So all these details are present in your agent card, right? So what happens is, sorry. Yeah, so these are the main actors. This is your end user, this is your client, this is your remote servers. Now, when a query comes in, when user sends a query to your orchestrator agent, the first step of your orchestrator agent is to figure out what agents do I have available and what agents can I use to fulfill this particular query, right? So uh, the agent cards, the name and the description of the agents from the agent card goes into the context of your orchestrator agent. And that's how your orchestrator agent figures out which agent it can use, right? So it works, the discovery mechanism works similar to how your tool calling works or your function calling works, right? So in tool calling, function calling also, you provide your name description, your schema details to the LLM model, and then the LLM decides which tool to call, right? Similarly, you are also passing what are the available agents. So you provide the name and the description to the LLM, and the LLM figures out, okay, this agent I can use to perform this task. So once the discovery happens, then the next step is to send the message or to exchange the messages with the remote servers. So this is where, like, there's a defined protocol of how this task is formed, how the message is structured, how the artifacts are structured, all of that. So we'll get into that in a bit. But this is a high level view of how the A2A communication works. First step is discovering the agent card, discovering the agent using the agent cards. And the second step is then sending that message to the agent, right? So then these are the four core objects that flows between an agent. So when you are sending a message to the remote agent, uh, the message can have these four objects. One is a message. Message is like a single turn of communication. It can have, like, it will have a role which can be user or an agent, and it can have then one or more parts. So it can have like artifacts, or it can have it can have text data, JSON data, raw bytes, whatever. But it is a single turn communication. Then a task is present in your object when your agent has initiated a task. So it is basically making, let's say, a tool call. So it has initiated that tool call. The tool call is in progress, it is waiting for a response. So it will create a task object where it will create a task ID, and it will send that task ID to the client along with the status of that particular task, that the task has been submitted, or the task is in progress, or the task requires an input. So task is a stateful unit of work with a managed life cycle. We'll understand the full life cycle of a task in a moment. Then there is artifact. Artifact is the output of the completed task. So it can be a file, it can be a JSON blob, or it can be an image URL or a plain text, right? Then the part is the atomic content. I mean, your part can have so inside a message or an artifact, it has a part object which can have a text data or a URL or a raw byte. This is just a structure of how your response looks like when the response from the remote server to the client. Okay, so task contains messages and produces artifacts. Messages contains parts. Uh, okay. We'll have a look at the structure as well. Let's move on. So we have discussed the problem. Okay. Now let's understand the whole task life cycle, right? So the first thing is the client always sends the uh, same call. So the client will send a message to the server, and then the server decides whether to respond inline, like it whether that communication is going to be stateless or whether that communication is going to be stateful. Now, what does stateless message mean? Stateless message means that it can answer immediately. It doesn't need any kind of orchestration. So whatever knowledge it has in the memory, it is just going to use that knowledge and it's going to respond back. So that is your stateless message. Stateful task, it requires orchestration, it requires streaming, or like uh, here it has given an example like mid-flight clarification. So we take this example of, let's say the client has sent this query, what is the time in Tokyo? Now, the time in Tokyo, it would probably have a time function and it can use that function and respond back, right? So it is a stateless message. It will use the stateless message and respond. But if it has to book a flight to Helsinki, then this would become a stateful task because it will first acknowledge the request, then it will send that request to the flight booking agent. The flight booking agent will need some more information. From where do you need the flight to be booked to Helsinki? What is the date? What kind of preferences, right? There would be a back and forth happening over here. So this would be a stateful task. Right? So for a stateful task, a task is created and then a task moves through these defined set of states, right? And these states are immutable. So a completed task can never be reopened. If something has to be done on a particular task or if something has to be revised, there will always be a new task which is opened, right? So here again, if we take this example of, let's say, book a flight, right? This is the message which is coming from your client. Then your client sends a message to the server. The server responds with the task ID and the state of the task ID that this task has been submitted. Then after some time, when it is in progress, so it will update the state saying that it is working. Then if it needs an input required, it will send this status update, right? And here the client and server are connected using the there is an open connection between the client and the server is using server sent events to send events from the server to the client. So this is we'll come to the capabilities part in a bit, but just have an understanding of how the task lifecycle works for now. Okay. So here again, so I think we have covered this. So when a server needs more information mid execution, it pauses and it transitions to input required. So here, when you send book flight to Helsinki, it has responded with the task ID and the state. It is working. Then the agent figures out that it needs more information. So it sends the state as input required and the question. Now, once the client receives this state input required, it will then respond back again using the message sent. So it will respond with the same task ID and the response of whatever was input required. Then this message has been acknowledged at the server. The server will change the status back to working. And then once it is completed, it will share the final response along with the artifact. Right now, there is something called as context ID. So context ID is for every conversation, a context ID is generated by your A2A client. And this context ID ensures that the conversation thread is maintained under that context ID, and the context ID remains same for one particular task or one particular conversation. So here, booking of the flight is your task. So until this task gets fulfilled, your context ID will remain same. So context ID will remain same for this whole thread, right? After this, if a query comes, and then if the query is still similar to this flight booking, then it will use the same context ID. If the context changes, then a new context ID will be created. So this logic is, again, I mean, you can programmatically define the logic if you want, or you can also give instructions to the LLM to create a new context ID if the context changes. So that's an implementation call which you have to take, right? Then the last thing is the tasks are immutable. So let's say you have given a task to book a flight, right? The client wants to book a flight and the task is to book a flight. The flight has been booked. Okay, this is again the example of the same context ID thing which I just spoke about. So because we are talking about the same itinerary, it is using the same context ID. But also the task immutability is about when your task is completed, then you cannot reopen the same task again. It would always be a new task which is initiated, even if it is related to the same context. So if you want to modify this booking of the flight, it would go under the same context ID, but a new task will be initiated, which would be modify this flight booking. So yeah, that's about the task immutability. Okay. Context ID is client generated identifier related, grouping related messages and task into logical sessions. The server uses it to reconstruct its LLM context window. Okay. So the client creates it, client generates a UID at the session start and passes it in every request, and server echoes it back, but server never creates it, right? When to rotate the context ID? Typically, the LLM reasoning layer decides a new context when the next task is unrelated or when prior history would be a privacy concern. Okay. Um, then let's move on to the next section, which is authorization. So authorization starts before the first message. So we have, when we saw the flow is that your client is sending, first gathering the agent card, right? And then once it figures out which agent to call, before sending the first message to that agent, if the agent card has the authorization section present, then it will read the authorization section. It will read what kind of authorization mechanism it follows, and it will first do the authentication before sending the message. Now, the authorization, it follows OAuth 2 flows. So it follows the client credential grant type. It follows all the, like there are 4 or 5 types in OAuth 2, right? It follows all of that. Here is an example of client credential. So in your agent card, in the security, it would be defined something like this. So your security schemes, it is defining OAuth 2, and in OAuth 2 it is following the client credential flow, and then this is the URL which it can use to generate the token, and it has also defined the scopes for which this URL is applicable. So if you are booking a flight, then you would like only for flight bookings will the token be applicable. Like whatever token is generated from this URL, that token scope is only for booking of the flights. If you use this token for a different scope, like something like hotel, this will give you a 401 or 403, right? So In the agent card, it will read this URL. It will then make a call, right? Using the token URL from the agent card, the client authenticates with the identity provider. The client ID and the client secret are the credentials received at the registration time. So, like this is a normal OR2 flow. If you are using this client credential grant type, then you would have to register your application with the identity provider beforehand, and at the time of the registration it will give you the client ID and the client secret, which you would save it in your keywords, right? So it will use those client credentials, and it will provide the scope for which it needs to generate that token. That scope will be provided in your post call. Now this will respond with your access token and also the expiry time, right? Now this access token will then be used to send further messages, right? So yeah, this is the example of machine to machine communication. There's no human login involved, right? So once you get the access token is attached to every request, and the access token goes into your HTTP authorization header. Uh, like that's the standard which you follow in your API, normal API communication. That's the standard which you follow here as well, right? So yeah, it goes to the gateway. The gateway validates the token at the edge. Here, all your rate limits apply, your WAF rules apply over here. Once your request is validated, then your request is forwarded to your server agent. Okay. So that was on the authorization. Yeah, this is again the server validates the token before the A2A logic runs. All 5 checks must pass, and failure at any step will return a 401 or a 403. So the first is obviously the connection needs to be TLS 1.2. Then this is all your validation of the token, validation of the scope, and if everything passes, then your request proceeds. Otherwise, it will throw a 401 or 401 or 403. Right? So again, this skill-based scope enforcement. So what we saw over here, right? The scope check. So if you are using the token and the token scope is only for, let's say, flight search and flight booking, if the agent uses that token and makes a cancel a flight call, or it is using that to book a hotel, that request will be denied. So this is the access management you would need, so that, because there is no human involved, agents are taking decisions of taking their own decisions. You need such kind of roles and permissions in place, and that roles and permissions, you can define the scope of your tokens basically in your authorization layer. Right? So scopes are declared in the agent card so that the client know exactly what to request before it even tries. Then the 3 communication modes which we spoke about. So in your agent card, there was a section for capabilities, right? Where we spoke about streaming and push notification. So A2A supports 3 distinct patterns for how client receives updates from the server, right? So the remote server in their agent card, they will define what capabilities they support. If they support streaming as true, then when we are so instead when if streaming is true, then instead of sending message send, instead of sending this or calling this method, the client will send message stream. So this would open up a persistent connection between the client and the server, and the server will keep pushing the events until the task is completed, right? So server pushes events as work progresses. um, I think server sent events is what most of our applications are using. If you're using Claude, sorry, is there a question? Okay. Server sent events is the communication method which a lot of these AI based applications are using. So you use Claude, Perplexity, ChatGPT. Uh, a lot of these applications are using server sent events where your client just sends the query once and then the server responds with the progress using events. So you send a query to the server will first accept that it is working on it, and then chunk by chunk, it will send the updates, right? So if the streaming is true, then instead of message send, a message stream goes in the request. So it would be message stream, or if it is an HTTP request, then it would be I'm forgetting the type, but it would be text stream, event stream, something of that sort that would go in the payload. If your if the streaming is not present, if in the capabilities nothing is present, let's say streaming is not there, push notification is not there, right? And you send a client sends a message to the server, going back to our flight booking example, right? So client sent a message to the server, server acknowledged it, it responded with a task ID, and it responded with the state submitted. Now the state submitted, task ID and state submitted means that the task is still in progress. The task has been initiated, but it is not completed. So in this scenario, there would be a synchronous polling, which the client would continuously, so the client would continuously poll the server until it gets a status completed and until it gets the final output. So this logic, all of this logic is abstracted in your SDKs. So if you are building agent using your Google ADK, or if you're using B framework, if you're using any kind of frameworks which has the A2A protocol baked into it, then you don't need to define all of these. Like the SDK will take care of these polling related tasks and all of that for you. Like you don't have to explicitly uh, mention that you have, like explicitly code for this polling. So there would be a method defined in your SDKs which would say send message, and that send message method will internally take care of the polling for you. But you need to understand how uh, the communication works, right? So yeah, if for in case of if in the capabilities you don't have push notification and streaming, then there would be a continuous polling done from the client until it gets the status as completed, right? We have spoken about the SSC streaming. Then the third is push notifications. Now push notifications is important if your task can take hours to complete, or it can take days to complete, right? So for tasks that takes hours or days, the client cannot hold the connection open. You cannot hold an open connection for that long. So that's where your client will send a webhook URL along with the request. So when the client is sending the message to the server, in that message it will send a push notification config, and in that push notification config will be a URL. So this is a webhook URL where you're telling the server, once your task is completed or whenever you have an update, you just post your update onto this URL. That's what you're saying. So client sends the message to the server, server acknowledges it, server gives you the task ID, then client can go offline, or it can forget that it has, like, it will send the task to the server, and it won't be expecting a response immediately. Now the server will start processing the task, and as and when it has an update, that update will it will just post that update into the webhook, and then this webhook, the client will basically read these updates from the webhook, right? So here your authorization works a bit different. You will first authorization you would need over here, right, before sending the first message. That's what we spoke about in the previous section. The second authorization you need is at this level. So when your server sends any update on the webhook URL, it will it will sign the payload with its private key. So it will do a JWT. It will send a signed payload, and then your client will use the public key and then fetch the data. It will validate that it is coming from the right server or the right agent, and then only it will use that update. Like, so it is just a validation check to make sure that the update is coming from the right agent. So yeah, that's a very like high level of how push notifications work. Then the last part is observability. Now your request is basically traversing through many different agents, right? How do you figure out if something goes wrong? How do you figure out where to look for, whom to ask, which agent to ask, what went wrong, right? So that's where your observability traceability comes into picture. So with A2A, it follows the W3C trace context, like which is the standard in HTTP headers. So basically there is a trace parent ID which gets generated for every request, and that trace parent, this ID spans across that particular request. So when the request starts until you receive the response, uh, it basically everything, all these steps fall under this ID, right? And then the agent to agent communication falls under a span ID. So once your request reaches an agent A, there would be a span ID created. Then if there is a handoff happening to agent B, then another span ID would be generated for that particular agent. But all of this will have the same parent header, and you can track your request using this header. So that is about observability, and I think that is all which I have from the concepts. If there are any questions, I can take. Otherwise, we'll quickly go through the GitHub setup, like the demo part. Okay. All right. Let me go through the demo. I'll publish the artifacts in the chat, or I'll share it with Sumit, and Sumit can share it with everyone.
Okay, thank you. First question I had in my mind, Nishi, was who owns this protocol then? Is it open? Is it from Google? Like who is?
It was initiated by Google, but they have donated it to Linux Foundation.
Okay.
So the A2A protocol was invented by Google. Then there was a agent communication protocol which IBM invented. Now they both have come together, and it is now one protocol, agent to agent protocol, and Linux Foundation is owning that.
Mm-hmm. They're open source and Linux is
Yes.
running that. Okay.
Yeah.
And how is the innovation happening in this area right now? Like I know, so it actually bought some structure, like it's a protocol, which means it defines the way you need to do for an agent to talk to another agent. And then I think there's two concepts. One is either talk one way, get some answers, or
Mhm.
basically keep the conversation open, which is the streaming way. Yeah.
Yeah.
So while so in terms of innovation, are they still contributing, or is it just like okay, this protocol V1, V2 is done? Or
It is still evolving. So
Mhm.
I think right now it supports HTTP, JSON RPC, SSE. There was communication going on to support gRPC and other
Yeah.
communication methods. And I think in terms of SDK also, they have a Python SDK. And there were plans of like rolling it out in other languages as well.
So there's no TypeScript version of this. It's only Python then.
I think there is a TypeScript. I have used only
Okay.
Python, but I
Okay.
think there should be a TypeScript version as well.
Okay. Okay. Let me quickly run through some of these questions. So it says, where does orchestrator agent discovery of available agents? So if you need to do discovery, where does that happen?
So discovery can happen in three ways. One is when you are defining your orchestrator agent, you can, in the orchestrator, you can define that these are the available agents to you. So you just define the host URL of your remote agents which you want your orchestrator to have access to. So you have like 5 agents, you give the URL of those 5 agents, and then your orchestrator will go and read the agent cards from for all those 5 and figure out which agent to use. That is one way of doing it. Second is you can also build a registry.
Hmm.
So like you have NPM registry, you have registry for skills, you have registry for MCPs also, right? You have registries for all those things. So you can have a registry for A2A, and then you can have an API, or you can have an intermediate layer, which basically looks at that registry and figures out what would be the best agent which you can use for this query. So that way it becomes very dynamic, right? You can add n number of agents to your registry, and then it is responsibility of that intermediary layer to figure out which
Which one
agent.
to call?
Yeah.
Okay. And is there a public version of that, or is it just basically do
There
your own?
isn't a public version yet, so this is mostly for your own solutioning.
So it's not like skills.sh kind of a thing where all the skills were published. Yeah.
No, 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 we don't have anything yet.
I think this was for skills, no skills.sh.
Yeah.
Yep. Okay. I think it's well, it's a question. I know the answer, but still, can it re-authenticate mid-call, maybe using token refresh?
Yeah.
Yep.
So it works same way as your APIs, right? So if your token has expired, you would want to do a refresh of that token, right? So
Mhm.
it works.
How to scope guardrails can be tested and strengthened to prevent scope creep, which means it's doing more than what it is what's supposed to do.
Guardrails is again your agent's decision, right? So guardrail will come under your remote agents per se. So it entirely depends on how you are configuring your agent, how you're defining guardrails within your agent. Uh, in terms of scope, I think scope checks we saw using the authorization, like you can define the scopes there. I'm not sure if that answers.
Mhm.
Can you?
Okay. Yep.
Yeah.
Thumbs up from Cam. Cam. Yeah. No other questions then. Yeah. Maybe you can continue.
Okay. Right. Uh, so this was a GitHub repo from Old Skinner. I think he is one of the contributors to the A2A protocol. He has created a healthcare agent. So this healthcare agent basically, if you ask it any questions, uh, it will go to the policy agent, the insurance agent provider, research agent, policy agent, and the insurance provider agent, and it will gather information for your query. So your healthcare agent is your orchestrator agent, right? So this is your client. This is your A2A orchestrator agent. And here, if you see, they have policy agent, research agent, provider agent. All these ports are configured over here. And if you see these agents are actually provided here in when. So this is how they are defining the orchestrator agent, right? This healthcare agent is your orchestrator, name, description, your LLM. And here the handoff is happening as a normal tool handoff. Now, this is how this framework implements it. If you look at ADK will have a separate handoff for tools, a separate handoff for agents. But this handoff tool basically takes care of all of the the methods which we spoke about. So this handoff has a run method, and that run method basically takes care of that send message function, or sending streams, or like push notification, all of the things which we have spoken about. This is abstracted away in this particular tool. So when they are creating an agent, you just wrap that agent into an handoff tool. So this is like you are defining the agents which the orchestrator can have access to. So here the policy agent, research agent, provider agent are provided, and the name and the description. You see the description from the agent card is basically going into the context of the orchestrator, right? Uh, so this is your client. This is your A2A client. Let's quickly go to the A2A servers as well. So if I go to the policy agent, now the main thing to note in your server agents or remote agents is your agent card, right? So this is your agent card. This is the name of the agent, insurance policy coverage agent. Here is the description, provides information about insurance policy coverage options and details. And then this is the URL which the orchestrator can use to communicate. What are the default input modes? What is the default output mode? So it only supports text. Then it doesn't support streaming. So streaming is false over here. And then it has defined the skill. You see the skills. Skills is simple. It provides the information about the insurance coverage options. Right? A very simple agent card. You can, right now this doesn't have any example of authorization, but you can also have like an advanced agent card, extended version of the agent card, which can have the authorization details. Right? This is again, the healthcare provider agent is also similar, very similar. And if you see, this provider agent is built using LangChain, right? This policy agent is built using the Google ADK framework. And then we had a research agent, right? Research agent is also built using research agent. Yes, yeah, this is also built using the Google ADK. I'm just trying to find the card for it. Where is the card for? Oh yeah, they have done the 2A2. So if you are building using the ADK, got it to the A2A server, you can just use this 2A2A function which they have, and it will convert your agent into a A2A server. Okay. Now let's try and run this. So we'll go to the healthcare client. The query is already like hard-coded over here. So the query, we are just asking that I'm based in Austin and how do I get mental health therapy near me? What does my insurance cover, right? Let's just run that. Right, so your A2A agent has started. So this is your healthcare agent has started. Okay. Right. Now, so the query went to the healthcare provider agent, and the healthcare provider agent was not able to get the proper response. I'm not sure what went wrong. But if you see the insurance provider agent response, your insurance policy covers mental health and behavioral health services. And then it has given the cost areas, the cost details as well. I think when I tried it previously, it worked. I think something is wrong with the agent itself. But you can see that the healthcare agent basically sent the request to the insurance, the policy, the provider agent and the research agent, and then it is fetching basically the responses, collating the response and then sending it to you. I would say I will share this repo as well, and there is also a concierge agent repo which they have, which builds the orchestrator using Google ADK. If you run that, you will be able to see the handoffs more clearly using ADK Web and the ADK UI. But because this was like the simplest implementation to understand, I thought I'll show this. Uh, I think that is it from my side. Over to you, Sumit.
Yeah. So I think people were asking about the link, so you're going to share the link later, no?
Yeah, I'll share the
Yeah.
link. Yeah.
And the GitHub.
Yes. I think GitHub repo someone shared. I think that's the GitHub
Yeah.
repo.
Yeah. Yeah. How did they do that? They actually typed everything, is it? While you were doing it. Okay. So any other questions or anything else from anyone before we close today? Anything? Is there an assignment, Nishi? Then we were thinking like what would be an assignment for something like this they would like to do, or
There's a concierge agent. Uh, what should I say? The Google.
is there a code lab?
It's a code lab. Yes, that's what it
Yeah.
is.
Okay. Maybe we can share that code lab for the concierge agent, and then we can, yeah.
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 Are there GitHub examples in TypeScript? And yes, there are GitHub examples for TypeScript. I can share the GitHub examples. Yeah, I'll share the code lab and all those details.
Yeah, and also maybe so I'll update the website with the links from today, and anything which Nishi gives us, and the assignment would be to finish the concierge demo. It's not important, this assignment, because this was a special session happening on the weekend. So really, I think whatever we kind of now we wanted to do something more advanced. So almost like 70 people here plus 110 active participants. Now you should be able to create an agent. You know what an agent is, what is an agent. So write discussions, and then finish our three assignments. The main three assignments for intro, what Renuka did, and the last session, and then anything else is basically a cherry on top. So thanks for doing it, and I would say everyone, please submit your assignments and the project before 19th, so I get enough time to go through what you have done, and then we can do the certificates, and hopefully we see you. I heard that we have a tube strike or something happening on that day, but we'll still continue because we somehow got the venue for that day. So please join us for the ceremony plus the watch party at New Day. Yeah. So this is the last session, and thank you so much for to Nishi. I can see a lot of people hearting you, and you want to share your LinkedIn so that they can follow you more. I think you're doing other sessions, some other places, no, right now?
Yeah.
Doing a session with GDG SX also?
I'm not doing one with GDG SX at the moment,
Mhm.
but I'll share more on my LinkedIn of the
Yeah.
sessions which I would be doing.
Yeah. Okay, that sounds good. All right, thanks. And no other questions, so we can actually then close the session today, and then you do everything on yours by yourself, and then please submit all the assignments and projects, and we will talk on Discord. Thank you, Nishi. Thank you for giving us this time.
Thank you.
Really appreciate. And bye, guys.
Bye.
The venue details and everything else is in our on the website. It's New Day. I think I just updated that. Last session is not a mandatory session, so everyone gets kind of a free attendance for that. But to clear the certification, you need 75% attendance plus finishing all the assignments and projects thing. Last time I mentioned I kind of created a new system also, buddy, so you can actually find a buddy, and both or more than one can actually work on the same project. So the whole idea is basically you learn something from the last 3 weeks of this dev camp. Awesome. Thank you, guys, and see you soon. Bye bye. Bye bye, Nishi. Thank you.
Bye.